Now let's try the highest. We have the max function, and I'll give this for statistics. I'll give this as a reference point. We can select any reference point, but I'm giving you different versions of or different approaches of deriving your results. So this is also another approach. You can do the same thing as what you did for economics, just that it's with the max function, and the columns that you shift would be 2. But this time it's statistics, where we are putting the starting point and max. Here under this, I'll use the offset function. This as the reference point. I want it to come down by 1 row, but do not go anywhere. Stay in the same column. Height will be 4 because we have 4 records here. Width will be 1. Close the bracket. Okay, I missed on closing the bracket for the max function, so I accept it, and here we have the max of these. That's 85. Now let us try a similar one for the lowest in accounting. So we say min offset. Now I can also put my starting point over here. Let's say I put my reference point over here. Now I want to take the minimum of the scores in accounting, and this starting point is somewhere within one of the scores of accounting, and that's absolutely fine. Now if you fall into this scenario or situation, how would you craft your function or your formula? So sitting in this position, I don't want the function to go anywhere. Don't move by any number of rows and don't move by any number of columns. You're at the right place. Now height, from here it's 4, but the rest of the cells are up over there, so height should be -4. That's 1, 2, 3, 4. And width, we are in the same column, so we don't need to worry about the width. We can keep that as 1. Close the bracket and close the bracket for min function. Hit enter. Here we have this, 37. So I've explained you different variation and how to get your desired results using the offset function. Now let me show you some real applicability of this function, which you can best relate to and probably would better appreciate as well. Let's come to sheet 2, and here we have some sales figures, monthly sales figures. Now I would like to calculate the year-to-month sales. Alright, now I would like to calculate the year-to-month sales. That means first year-to-month. Now this is a cycle of Jan to December. So it starts from 45 in January. February, it's 49. So the cumulative figure would be something like 94.5. Okay. So in other words, I can say that we need to calculate the cumulative sales for each year until each month. So this should be something like, first it should be 45, then it should be something like this plus this, and goes on until December. This is perfect, but I cannot apply this formula to the right over here because this is a new year, and for January it should be this, and then again previous month plus 1 plus the current month figure. And this is the desired result, but I'm not able to get a single function or a single formula to sort it at one shot. And this is where we'll make the best use of the offset function. Let me clear this off. So I would say sum offset, and under the offset function, we'll have this as the starting point. And I do not want the function to move by any number of rows and neither by any number of columns. Now the height would be 1 because we are focusing on just one row. Now when we say the width, here I would say minus month function and C2. Now let me explain you what exactly is happening here. But first let me close the bracket and show you the result of how this works. First let me show you the output. Here we have this, take a look. 2 months total, it's 94, and 6 months total, it's 349.7, that's perfect here. And what is the annual total? It's 971.1. We get that. And what about January? Here we have this again. 142.8. And then again the count increases. It keeps on accumulating. So we have got a year to month figures over here. If you are talking about the month of August 2020, till this month, the total sales was 518.7, and that's what we have here. If you are sitting in the month of January, that's the first month of the year, so it's only for that month that you get the figures for. And it keeps on adding or accumulating for subsequent months. Now, what exactly happened over here? What did we do? Why did I specify the month over here as the width? Well, what exactly is this month function doing? And it's a minus over here that I've used. That means when I'm using the negative sign over here, it's going backwards. It's the width. That means from left to right or right to left, the number of columns to be covered. So it's a negative here. So what exactly is this month function doing here? Let me show you. We have the month and the current date, close the bracket. You see, it's 1. Now, what if I were to select this further? Well, this is obvious, isn't it? That's obvious. So we are getting the month number for each of these months, and that's perfectly fine. But how did it help with the width? Now, when I specified the width with a minus and this month, it's -1, so it is only selecting one cell. But the moment you come to the next few months, let's say we are talking about the third month. So we are in the third month, and that means the width is -3, which means sitting over here, the offset function will select last 3 cells, the current and last 2 cells. Now sitting in the 5th month, if month is -5, so here the width is -5. With the help of month function, we got the number 5. So from here, it goes 1, 2, 3, 4, 5. That's it. If you are sitting in the month of December, that's 12. And so it's the width that we had specified was with the minus sign. So that's -12. We say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you have the entire figure. Now coming on to the next year, that's January. I apply the same logic here, but this time the month number is just 1. So it's not going to go anywhere because the width specified is just 1. Now be it +1 or -1, it does not matter. It stays where it is. And coming back to subsequent months here, you can see for the second month, it's -2. So again, it takes -2. It is least concerned about the other ones. And here -3 as the width. So that's how dynamic it is. The trick is in how well you use the function in Excel to derive your desired results. That's the art there. It's not just about knowing functions, but it is the skill on about how well you can use the knowledge that you have gained or the functions that you have learned. So here, in order to escape out of the scenario wherein in January it should not select the cells from previous year, I made the best use by using the month function. For August, it's the last 8 months. For September, last 9 months, and so on. So this month function gave me the width. That's in the width section in the offset function. Now the other two is kind of geeky, but it's a bonus from my end here, and it could be tricky. For that, let me just explain you the target over here. So I want to find out the quarterly sales. So Jan, Feb, March makes 1 quarter. So I need the number over here for the sum of these 3. So that should be something like sum and these 3. We have this here. And then again, it's April, May, June. We need here. And then July, August, September. We need here. December and here. So you see, it's just the quarterly sales. It's least concerned about if it is June, it's only showing about the last 3 months and not for Jan to June. This is a different target or a different objective that we have for this particular row. and it's only taking a sum of last 3 months. And we need to ensure that it's not calculating the score for, or rather the total sales for the last 3 months in any of the cells in the middle. For example, August. If you select the last 3 months, it's not one quarter by a financial calculator or going by the calculator, because the quarter starts from, your calendar starts from January and hence it's the 3 quarters here. Right now, August is falling somewhere in the middle of a quarter. That is not helping. So how do I get this? Let me show you. I'll clear this off. Now, before we proceed further, we need to first identify which months should we have the result appearing in. And quarterly sales, when you say quarterly, let me add just one more column over here. I say insert. Now that's quite a long column here. Let me just shrink this to this much. And here I would mention quarterly. How many months do we have in a quarter? It's 3 months. So there is an interesting function called as GCD. That's greatest common divisor. Now what exactly this happens? Let me tell you that. Okay, first let me get the result and I'll explain you. For those who are not very comfortable with arithmetic or mathematics, I'll explain that in a moment. For now, I want to know the greatest common divisor. GCD is the greatest common divisor between two numbers. So 1, it's this. And let me log the column reference here, comma, the month number of the current month. Close bracket, you have this. Now let me expand this formula ahead and show you what exactly is happening here. So 113, 113, 113, and so on. And notice something over here. Every time it's the last month of the quarter, we have a number 3 in place here. Right? So this acts as a good measure or a good way to identify the month when the GCD is 3, only then calculate the last 3 months total. Otherwise, don't calculate, just leave it. That's exactly what we'll be doing. Okay, now before that, let me just explain you the concept of this GCD function. Now in arithmetics, we would have studied about greatest common divisor. What does that mean? Now this is 1, the month number. Okay, it's Jan, right? We have the month function. It's January. These are months. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then again 1, 2, 3. So what exactly is happening here? 3. 3 can be divided by 1 as well as by 3. 3 can be divided by 1 and 3. But in case of January, it's number 1 as the month number. So 1 can be divided by number 1 itself. Now here again, if you were to take a GCD of 3 and 2, 3 can be divided by 1 and 3, we know that, and 2 can be divided by 1 and 2. Now what is common over here? The common divisor in this list, it's 1. So 1 is the answer over here, that's the common divisor. Again, what is common in these two? 1 can divide 3 and 1 can divide 2, so 1 is common here. Now what about this? 3 and 3, so 3 can be divided by 1 and 3. And this particular month number, which is also 3, can be divided by 1 and 3. Now, which are the common numbers here? 1 and 3. And which of them is the greatest? It's number 3. So we have this here. Similarly, we have April, which is number 4. And 4 can be divided by 1. It can be divided by 2 as well as 4. Now, let me put this down. This is the month divisor over here. This is a month's divisor, and this is the divisors of 3. So we have 4, which can be divided by 1, 2, as well as by 4. But when it comes to 3, it's 1 and 3. That's it. So which are the common numbers in both these? It's 1. So we have this 1 here. Now moving on, it's 1 and 3 again. This will be consistent across for all of them, because we are just looking at divisors of 3. 3 can be divided by 1 and 3 only. But now when it comes to May, that's number 5. So 5 can be divided by 1 and number 5 itself. So what is common? It's 1. Now 6 can be divided by 1, 2, and 3. And what is common over here? We have 1 as well as 3. But which of them is the greatest? It's 3. So that is the reason we say GCD, which is greatest common divisor. So all these are divisors, and amongst them the greatest is number 3 in this list. It can be divided, but 1 as well as 3 can divide it. That's number 6 for June and number 3. But the greatest of the lot is number 3. Hence, 3 is the answer. So when we applied GCD over here, the GCD function, it just took the greatest of the common multiples or the common divisors here, and we have this result here. So we have 1, 1, 3, that's matching. Again, 1, 1, 3, that's exactly matching, and it will go on. So this is the logic applied over here, and we get this result. How do I apply this? Let me show you. So I say if GCD of number 3, because it's a quarterly, and in a quarter we have 3 months. Let me lock the column over here. And then month, that's the current month number. We are in January, so that's current month number. Close bracket, equals to 3. That is, the GCD value is equal to 3. Only then use the sum function, and under that you have the offset function. We take, here we are, so we take this as the reference point, and under this we say 0. Don't move by any number of rows and don't move by any number of columns. Let the height be 1 and width be minus whatever quarterly, the time span that you have, and again lock the column here. This is minus 3. But we are using the reference here. We have this. Now close this bracket for the innermost offset function and then close the bracket for sum function. Well, in case if the GCD equals 3, we can execute the sum function, but what if it's not equal to 3? I would just put double quotes here, a pair of double quotes, which means blank cell. Close the if function and you have this. Now I copy this function all the way to the right, and here we have this. Let me show you what's happening here. If GCD of this number 3 and the month number, current month number, is equal to 3, only then take a sum of this, whatever selected within the offset function. That's here. From here, don't go anywhere from this purple cell. The height is 1 and move left or select cells towards the left, but the width is 3. And if you don't find it, if it's not equal to 3, then just leave a blank cell here with double quotes. And that's it. We have it here. Now this is slightly a notch above, but that's an interesting one here we have. Try the same thing for half yearly sales. Now for half yearly sales, it's 6. Okay, it's 6 months in half a year. So this time instead of 3, 3, 3, okay, we have 3 over here. Let's try this with 6. So we need the divisors of 6 and the month divisors. Let me just clear this off, or rather let me just change this with the blue cell with the 6. So that means the GCD of number 6 and the current month number. We hit enter and copy the formula to the right, and you see 1, 2, 3, 2, 1, 6. 1, 2, 3, 2, 1, 6. So here we have 6 over here twice. That's 2 half a years. How did this happen? Well, what are the divisors of 6? It's 1, 2, 3, and number 6, of course. So 1, 2, 3, and 6 is constant across because we are referring to divisors of 6. What about the month divisor for January? It's 1. What about February? It's 1 and 2. And March, it's 1 and 3. 4, it's April. That's month number 4. So 1, 2, 4. May, it's 1 and 5. June, it's 1, 2, 3, and 6. Why? Because it's month of June and that's 6. That should be the same. And now what about July? It's 1 and 7. August, it's 1, 2, 4, and 8. Why? August is for month is number 8. So 1, 2, 4, and 8. All of these can divide the number 8. What about 9? September is number 9. So 1, 3, and 9. October, it's 1, 2, and 5. Apart from this, there is no other number that can divide number 10 of October. Moving on, November, it's 11, 1 and 11, and 12. For December, it's 1, 2 can divide 12, 3 can divide 12, 4 can also divide 12, 5 cannot, but 6 can divide 12, 7, 8, 9, 10, 11, none of them can divide 12, but 12 itself can divide 12. So now just take a quick look. Which is the common over here? It's 1. Here, which is the most common here? 1 and 2. Which is the greatest of the two? That's number 2. Now here, what are common? 1 and 3. Which is the greatest? It's 3. Here we have 1, 2, and it's common again. So greatest is 2. Here only 1 is common, so we have 1. Here we have all the numbers in common, but the greatest of the lot is number 6. So we have number 6 here. Again, here 1 is common. And here we have 2 in common. Then we have 3 in common over here. 1 and 3 are common, and the greatest of them is number 3. So 3. Here again, 1 and 2. Greatest is 2. 1 is common over here. And here 1, 2, 3, and 6. All 4 numbers are common here. So the greatest of the common ones are 6. So greatest common divisor. So now for Jan and Feb, it's again the same story here. So we don't need to worry. So 6 and 6. That is the time. That's for June and December. That's the time when it's half year. So we need to apply the same logic what we have applied here and try it out. So we have if the GCD of this and lock the column and current month number. Now this time the GCD equals to 6 only when the GCD, these are the greatest common divisors that we have manually calculated, and the greatest of the lot is number 6. Only then use the sum function with the offset. A reference point, let's have the current month sales reference point. Don't go by any number of rows and don't move by any number of columns. Let height be 1 because we are only selecting 1 row. Now what about the width? It should be minus the span within the half a year, within half a year. So let's lock the column and close the offset bracket and then the bracket for sum function. Now, what if it does not match? Then just apply double quotes, a pair of double quotes, and close the if function. Hit enter, you have this. Now this function is very much same as this function. Only difference is we have to replace number 3 with 6 over here. Rest everything function would have been same. Let's apply to this right and see. Here we have June. 6 months. Total sales is 349.7. Let's add them up here and see. Yes, the sum is 349.7. And let's check this out. 621.4. That's it. So now that's an interesting one. Here we just have 3 months. So we were able to get a quarterly figure. But had we had more 3 months, then probably we would also get another 6 month set of data. And this is the beauty. The offset function can just help you select dynamically. Now, if I were to change, let's say here, instead of 6, if it was 3. Okay, what happened? Now, I want to make this much more robust and dynamic. So here, instead of manually entering number 6, I would want to select this cell itself, because this itself is number 6. And this makes my model or this particular set of tool that I've created more robust. Instead of manually entering number 6, I've referred to this cell and locked the column reference. Now let me copy paste this formula. This is perfect. Now if I were to make this quarterly, then I just need to replace 6 with 3 and hit enter. And here we have the quarterly figures. What if this was a bi-monthly? So I select 2, hit enter, and we have the totals for every 2 months. That's how dynamic this becomes, right? So here we have this. Again, in this function as well, I had manually entered number 3. We might want to just refer to this 3 over here and lock the reference. Because if I were to not change this to number 3 and I just hit enter and change this to 6, you see, there is inconsistency here, right? What is 466 here? 1, 2, 3, 4, 5, 6. Here we have the last 6 over here, which is perfectly fine, but in the month of September, that's a bit of odd. So that's inconsistency. It would be better if we have the function more dynamic with less hard-coded numbers. So we'll change this reference to this and ensure that we have the column locked. Hit enter and copy paste it to the right and enjoy. Let's test it out. I want it bi-monthly. I change it to number 2. We have this, right? So it's quite a versatile function that can help you in real tricky situations. And the core purpose of the offset function is dynamic selection or dynamic range selection. And that's very critical when you're working on complex structures within Excel. Well, that's all from my end.